Welcome to our review on specific latent heat. First thing then is at the top there I've just given you a little reminder about what the particles look like in solids, liquids and gases. So on the far left hand side we can see the particles in a solid, all neatly arranged in regular rows, all touching each other with no gaps. In the middle we've got our liquid, which is where the particles are still all touching each other, but they're no longer arranged in these regular rows. And finally on the right hand side we've got our gas, where the particles are now spaced out. Do remember the change of state that we have from a solid to a liquid is going to be melting, liquid to a gas evaporating, gas to liquid is condensing, and liquid to solid is going to be freezing. So what we actually find then is if we've got our solid and we heat it up, then what we find is the temperature actually rises steadily until it reaches the melting point. What we then find is the temperature actually remains constant throughout that process of the solid melting. Once the solid's then melted, the temperature is going to continue to rise at a constant rate until we reach the boiling point, at which point the temperature rise then stays the same, so we get that constant plateau once more, and then after it's obviously all turned into a gas, the temperature will then increase once more. This is the kind of graph that you might be asked to either sketch or to actually interpret about these changes of state and the temperature associated. So if you have a look at the bottom left first of all, we can see we start at -18, and then that little diagonal line shows us that the ice is warming up. So that temperature continues to increase until we get to 0 degrees, which is obviously that melting point. At that point the temperature levels off, it stays at 0 while the ice melts. Once all the ice has melted and become that liquid, what we see is the water then heats up from 0 all the way up to 100. Once we reach 100, which is the boiling point of our water, then again we see that line level off. And again, once all of that has then become steam, so it's turned into a gas, the temperature can increase once more. This is where we come on to see our second calculation of the topic, which is to do with this thing called specific latent heat. Now, when we're talking about the specific latent heat, what we're referring to is the amount of energy needed to change the state of 1 kilogram of the substance. So by change the state, we mean change it from solid to liquid, liquid to gas, or vice versa. So what we actually find is there are two values associated with this. So we would have the specific latent heat of fusion, which is the energy needed to melt 1 kilogram of a substance, so to change it from a solid to a liquid, and that's also the same if we're going from liquid to solid. And also we have the specific latent heat of vaporization, which is the energy needed to boil and evaporate 1 kilogram of a substance, so that's going from a liquid to a gas and vice versa. So on page 2 of your exam booklet you'll find this calculation. So the energy in joules is the specific latent heat measured in joules per kilogram times by the mass in kilograms. Example of a kind of question you might well get then: how much energy is needed to melt 2 kilograms of ice? The specific latent heat of fusion for water is 334 joules per kilogram. So if we look back to page 2, we find our equation. So energy is specific latent heat times mass, and then we substitute in the numbers from our question. So we know the specific latent heat is 334 and the mass is 2. So 334 times 2 gives us our energy of 668 joules. The one thing to bear in mind about this is they're quite likely to give you a table in the question which has got 2-3 different substances, and they will give you the values for the specific latent heat of fusion and the specific latent heat of vaporization for them. So you need to read the question carefully to identify which of those numbers to use. So do make sure that you remember fusion is the solid to liquid, vaporization liquid to gas.